In this video, I'm going to finish the KutaSoftware free worksheet under the Infinite Algebra 2 section, Graphing Linear Inequalities, picking up where I left off with number 9. Y is greater than or equal to 5. That means, regardless of the x value, y will always be 5. And since it's greater than or equal to, that's going to be a solid line. Now that I've graphed my line, I need to figure out which side of the line I'm going to shade. Below the line, I have values of y that are less than 5, so I'm going to shade above the line for values that are greater than or equal to 5. Let's move on to number 10. In number 10, I'm going to put this in slope-intercept form. So I'm going to subtract 2x from both sides. That'll give me that negative 5y is less than or equal to negative 2x plus 10. Then I'll divide both sides by negative 5. In doing that, I'm going to have to flip the inequality. So I'll have that positive y is greater than or equal to negative 2x divided by negative 5, which is positive 2/5 x, plus 10 divided by negative 5, which is negative 2. So my slope m is equal to 2/5, and my y-intercept b is negative 2. So I'm going to plot point 0, negative 2, and then use my slope to find the next point, going up 2, and then 5 to the right. Now, since this is greater than or equal to, or the original was a less than or equal to, I know that I'm going to have a solid line. So I'm going to connect those 2 points using a solid line. My next step is to use a test point to decide which side of the line I'm going to shade in. Let's use the point 0, 0. And I can plug that into my original inequality or my new inequality. Let's plug it into the original. So I have 2x minus 5y is less than or equal to 10. So if I plug in 0.00, I'll get 2 times 0 minus 5 times 0 is less than or equal to 10. And I need to see if this inequality is true. 2 times 0 is 0, minus 5 times 0 is 0, and I have less than or equal to 10, and 0 is indeed less than or equal to 10. Therefore, I'm going to shade in the region that contains the point 0, 0. Let's move on to number 11. In number 11, I'll subtract 8x from both sides of the inequality to get that negative 3y is less than or equal to negative 8x plus 12. Then I'll divide by negative 3. When I divide by a negative, remember, I'm flipping the inequality. So I'll have y is greater than or equal to negative 8x over negative 3, which is 8/3 x, plus 12 divided by negative 3, which is negative 4. My slope m is going to be positive 8/3, and my y-intercept b is a negative 4. So I'm going to plot 0, negative 4, and then use the slope to find my next point, going up 8 and over 3 to the point 3, 4. Now, since this is a less than or equal to, or greater than or equal to, I'm going to connect those using a solid line. And then I'm going to use a test point to figure out which region I'm going to shade. I'll use the test point 0, 0. And I'll go ahead and plug that into my new inequality. So y is greater than or equal to 8/3 x plus negative 4. Plugging 0 in for y and 0 in for x, I'll see if this inequality is true. I'll get that 0 is greater than or equal to 0 plus negative 4, so I'll have 0 is greater than or equal to negative 4, and that is indeed true. Therefore, I'm going to shade in the region that contains the point 0, 0. And lastly, for this set of directions, number 12. I'll start off number 12 by adding y to both sides. In doing this, I'll get that x is greater than or equal to y. I could also say y is less than or equal to x. You can see my slope m is equal to 1 and b is 0 since I am not adding anything to the x. So point 0, 0 is where I intersect the y-axis, or my y-intercept lies, and then I'm going up 1 and over 1 with my slope, since 1 is the same as 1 over 1. And since this is greater than or equal to or less than or equal to, I'm going to connect those points with a solid line. And now I just have to decide which region I'm going to shade. However, 0, 0 falls on the line, so I'm going to have to use a different test point. Let's use the point 1, 0. So I'm going to plug 1 in for x and 0 in for y. So I have y is less than or equal to x. I'm plugging 0 in for x and 1 in for y. And 0 is indeed less than or equal to 1. Therefore, I'm shading the region that contains the point 1, 0. And that's my solution in number 12. Continuing on to the critical thinking questions, number 13 says to name one particular solution to number 11. So going back up to number 11, naming one solution, well, you can see that our test point 0, 0 was in the shaded region, so 0, 0 is a viable answer. So essentially, we can pick any point within the shaded region or on the line, since our line is also shaded. So we chose point 0, 0, but you could choose any point within the shaded region, including the boundary, which was the line we graphed. For number 14, it asks, can you write a linear inequality whose solution contains only points with positive x values and positive y values? Why or why not? So looking at our coordinate system, positive x values and positive y values are only in the upper right quadrant, quadrant number 1. So it is not possible to write a linear inequality because since it's linear, it's a line, and a line continues on in whichever direction it's drawn. For example, if we were to draw a vertical line, we would have to continue that on down into the next quadrant, would give us positive x values but negative y values. If we were to draw a horizontal line, that would continue on into the quadrant that gives us negative x values and positive y values. And if we were to try it and draw a diagonal line, we would eventually continue on into a quadrant with negative x values and negative y values, and potentially intersect other quadrants at the same time. Therefore, it's not possible because no line can be only in the first quadrant. So no, a line cannot be only in the first quadrant with positive x values and positive y values. And with that, we wrap up the Graphing Linear Inequalities worksheet under the Algebra 2 section. Go ahead, give me a thumbs up on this video, and subscribe to my channel. All likes and subscriptions are greatly appreciated, and let me know that you're finding these videos helpful. Also, if you have any questions or need further clarification on any of the problems within this video, leave a comment below.